20 minutes after we started. This is section 7.2, multiplying polynomials. Now, we have 2 days on section 7.2. 2 days, today and tomorrow. And honestly, a third day on Friday, too. But it's just like special products. But for our purposes right now, we're just going to be multiplying polynomials. Now, what types of polynomials do we know right now? We know monomials, binomials, and trinomials, right? Those are the 3 types of polynomials that we've been working with. So that's what we're going to do today. We're going to multiply monomials together. We're going to multiply binomials together. And then we're going to work on multiplying trinomials together. All right? So let's start small. Now, to start this, we need to remind ourselves of this fact. If you multiply 2 bases, 2 like bases, multiply, not add. If you multiply 2 bases together that are the same, like if you had x squared times x to the third. Remember, our product property says that you would add those exponents together, correct? X to the second times x to the third would be x to the fifth. Another example of this is if I had said, x to the seventh times x to the third, that would obviously be x to the what? 10th, right? When I am multiplying with bases, I add exponents. We've learned that. That was back in section 6.1. Now, to multiply polynomials, we are going to need that every single time. So let's start small. What's the most basic polynomial that we can have? A monomial. So let's take monomials and multiply them together and see what happens. For example, I've got 6y to the third times 3y to the fifth. Now, let me ask you, do you see any addition subtraction signs? No. So should there be a need to use the distributive property? No. There should be no need to use the distributive property. Okay? Now, what's the only thing those parentheses are telling you? That it's multiplication. So essentially, this is where we're at. 6y to the third times 3y to the fifth. Now, what's the operation in between the 6 and the y to the third? Multiplication. What's the operation in between the 3 and the y to the fifth? Multiplication. So you're saying here that I've got multiplication everywhere? That means that I could group in any order and it will not change the outcome. Here's what I mean by that. What I can do is multiply the 6 and the 3 together. I can group them together. What is 6 times 3? 18. And then I can group together the y to the third and the y to the fifth. What is y to the third times y to the fifth? Y to the eighth. Add exponents together. And that's what I have when I multiply those 2 monomials together. So essentially, I'm just multiplying common pieces together. 18y to the 8th here. 18y to the 8th. Okay. Let's do that again. These are 2 monomials again, right? Okay, so again, 2 monomials multiplied together. I could just multiply common pieces together. Guys, those of you, can we put our computers away? Do that on your own time. Yeah? Do that on your own time. Not in class. No, do it on your own time. Shut up. We got 3 times 9. Multiply common pieces together. 3 times 9 is 27. What do I get when I multiply those m's together? 4. 4. 1. 2. I take m to the first times m to the third. Oh, I just said it. M to the first times m to the second is m to the third. I add exponents together. Be careful about that. Don't forget that there's an m to the first there. Same thing here with my n's, actually. N to the second, n to the first makes a full n to the third. Let's do that one more time. Now, does the property still hold when we have more than 2 monomials?
Yes.
Yeah. I could do as many monomials as I want. All I'm going to do is just keep grouping all the numbers together and then all the letters together. For example here, I'm going to take the 2, the 5, and the 1/2. What is 2 times 5 times 1/2? 5, because that's 2 times 5 is 10. 10 times 1/2 is 5. And then I'm going to take x squared, x to the first, x squared. What's my final power on x? 5. 2 plus 1 plus 2. And then I take a y to the first, y to the fourth, y to the third. Final power on y? 8. Good. Okay. So those are the rules for monomials. Multiplying a monomial times as many monomials as you want. Monomial times a monomial, you just multiply the common pieces together. Numbers go together, letters go together, then you're done. Just don't forget to add exponents when you're multiplying the letters, variables. All right, so now let's take a look. Let's keep building. Let's take a monomial and multiply it by a polynomial. So like, for example, here we have a monomial times a trinomial. Now, do you see addition and subtraction signs? Yes. That tells you you must use the distributive property. Here's what I mean by that. I'm going to take this 4x and I'm going to distribute it in to each piece on the inside. Okay? I'm going to take that 4x and I'm going to multiply. And again, how do I know I multiply with the distributive property? Because what is the operation between the 4x and the parenthesis? Multiplication. Don't forget, when you are distributing, you must use multiplication. So I have 4x times 3x squared. What does that give me? 12x to the third. I have 4x times 4x. What's that get me?
16x to the second.
16x squared, 16x to the second.
So you're basically adding the x's together and multiplying.
Add the exponents. Multiply the numbers. Brianna?
Did you get the 12 from timesing the 4 and the 3?
Yeah. Multiply the numbers together, multiply the letters together. Because that's essentially what I'm doing, right? I'm taking a monomial times this monomial.
Yeah.
Multiply the numbers together, multiply the letters together.
When we're multiplying the numbers together, isn't it, well, the letters, isn't it just adding?
Yep.
Because when you say multiplying, it can be...
Well, multiply the bases, you add the exponents. Okay? So, yes, it is still multiplication. The operation is multiplication, but what I do with the exponents is I add them. Okay? So now I have 4x times negative 8. 4 times negative 8 is negative 32, and the x gets carried along for the ride. So this is a monomial times a trinomial. Okay. So essentially, if I have a monomial times any sort of polynomial, I'm just going to use the distributive property. Same thing here. This is a monomial times a binomial. Question?
Wouldn't you simplify it?
Could I? Could I have simplified that?
Yeah.
No, because I am adding and subtracting. These would have to be like terms to be able to simplify those. And that's a good point to bring up. Like, somebody asked me last period, so you can multiply 4x and 3x squared, even though this is not a 4x squared? And I said, correct. They don't have to be like terms for multiplication. You don't need like terms for multiplication. You know what we needed like terms for? Addition and subtraction, what we did yesterday, right? We don't need like terms for multiplication. So that's why I can multiply these however I want, no matter the terms. Like, for example, on this one, distribute in the negative 6. All right, negative 6w squared times 2w. Well, negative 6 times 2 is a negative 12. What's my power on w?
3
to the third. You see that? Even though that wasn't a 2w squared, I could still multiply it. And then I take this negative 6w times, be careful here, I'm going to consider that a negative 5. Because a negative times a negative is a positive. Plus 30, and the w squared gets carried along for the ride. Can I combine those terms in the end? No, because one is a w to the third and one is a w squared. And there's an addition sign between them, and I cannot add without exact like terms. Now this next one. This one looks weird. Don't let that deceive you. You know what I'm going to distribute in? Yeah, and I'm just going to kind of like backwards distribute it. Okay? Yeah, you can do that. So I have a 3m to the 4th times 12. 3 times 12 is 36. M to the 4th gets carried along. And then I have 2m to the 3rd times 3m to the 4th. 2 times 3 is 6. 3 plus 4 is 7. 6m to the 7th. Now, I would take off a point for that answer. Why? Brianna? It's not in standard form. Yeah, this 6m to the 7th should come first. That's my true answer. Every answer should be in standard form if it applies. Okay? And I would have to take off if it's not. Okay, so that's monomial times any polynomial. You know what we have now? Now, this is not on your papers. Please just watch here. Please don't flip to the back and start working. Please don't do that. Somebody did that and they did it all at the back all around. Take a look here. What do I have now? I have a binomial times a binomial, right? I have a binomial times a binomial. X plus 3 times x plus 2. I have a 2-term times a 2-term. So now we've graduated from monomials to binomials. Now when we have that, I'm still going to use the distributive property. But here's what I have to do. I have to take x and I have to distribute it in. But I haven't worked with the 3 yet. So then I would have to take 3 and distribute it in as well. It's kind of like a double distributive property problem. So what would that mean? Well, that would mean that I would take x times x, x squared, and then x times 2, 2x. And then take 3 times x, 3x, and then 3 times 2 to get 6. Now, this is our first example where, what do you see happening in the middle? This I can combine like terms. Are 2x and 3x like terms? So then I'm going to put those together. X squared plus 5x plus 6. And that would be my answer here. Now, some people find that really confusing. Some people think the order is really weird to remember how to do things in. In my mind, I'm like, oh, sweet, it's just the distributive property twice. But some people, that really gets jumbled in their head. So you know what somebody came up with a long time ago? It's this thing called the FOIL method, which is at the bottom of your front page, and that's where you should be now. This thing called the FOIL method. If you ask anybody that's passed Algebra 1 ever, and they say, and I ask them, what's the FOIL method? They'd be like, oh, I know what that is. I can FOIL something. They know what that is. But honestly, FOILing is just a fancy way to remember to use the distributive property. Now, what does FOIL actually mean? FOIL is just an acronym. It's just a way to remember, using the first letters of each thing, a way to remember how to multiply a binomial times a binomial. F standing for first. O standing for outer. I standing for inner. L standing for last. First, outer, inner, last. Take a look at the example that we have. Like in terms of my x plus 2x plus 3. My first terms are just my first 2 terms of the binomial. My outer 2 terms are just my outer terms of each binomial. My inner 2 terms are just my inner 2 pieces of each binomial. And my last 2 terms are my last 2 pieces of the binomial. So I'm doing the distributive property. I'm just reminding myself how to do it by remembering the word FOIL. First, outer, inner, last. First, outer, inner, last. So let me show you what an example would look like. Now, this is on the top of your back page. X plus 4 times x minus 2. X plus 4 times x minus 2. So I like to encourage you guys to write the word FOIL up on the top of the page to remind yourself remind yourself the order. Okay? So for example here, x plus 4 times x minus 2. First, the f standing for first. X times x is x to the second. X squared. Question?
On our test, is it gonna be like, are you gonna tell us like which one is which? Like,
No, you have to know that. That's
the question. We have to know like binomial. Okay.
You have to know which method to use.
Alright.
Outer. O is outer. X and negative 2. Minus 2x. I is inner. 4 and x. Or x. L is last. 4 and negative 2. Minus 8. Again, you're multiplying each piece of that. Firsts, outers, inners, lasts. Now, what can I do in the middle here? To finish it off, combine like terms. X squared plus 2x minus 8. And that's my answer.
Why did you combine these terms if that's technically a -2, but on the other side we want 8?
Because they have to have the same power. It doesn't matter about the numbers in front. They have to be the same variable raised to the same power. If that's the case, then you can combine them, no matter what numbers are in front. Let's do another example, shall we? Again, we're using the FOIL method here. F standing for firsts. 2y times 3y. 6y squared. O for outer. 2y times 2. 4y. Inner. Negative 5 times 3y. Minus 15y. Lasts. Negative 5, positive 2. Minus 10. You know what the common thing to do there is? I always see people adding on the end, like negative 5 and 2 make negative 3. No, remind yourself that it's all multiplication. And then we combine like terms on the inside. 4y and minus 15y, negative 11. Minus 10. See, the nice thing about the FOIL method is that if the problem is originally started in standard form, then you're going to be able to keep it in standard form without doing any reordering in the end. Let's do another one. 4x minus 3 times 2x minus 1. So use the FOIL method again. So I'm going to write it out here. F-O-I-L. F. First. 4x, 2x. The first terms out of each binomial. 4x times 2x is 8x squared. Outers. 4x and a negative 1. Negative 4x. Inners. Negative 3, 2x. Minus 6x. Lasts. Negative 3, negative 1. Watch out for that. That should be a plus 3 sitting out there in the end. Negative 3 times negative 1 is a positive 3. And then we combine like terms in the middle. 8x squared minus 10x plus 3. Negative 4 and negative 6 make negative 10. Okay. Questions about that one? Now we got one more problem to do. And I would venture to guess, just like I see Gio did right here, that a lot of people might try to tell me that this answer is 9x squared minus 16 because you see that it's squared. And you're like, oh yeah, just bring that thing in. Just bring that squared in. Let's finish the problem. 9x squared, 16. If it were only that easy. Guys, what does squaring something actually mean?
Slicing it by
timesing it by itself, right? 3x minus 4 times 3x minus 4. So wouldn't this lend it, looking at this, doesn't this lend itself to the FOIL method? Right? I have a binomial times a binomial. So let's do it. F for firsts. 3x times 3x. 9x squared. Okay, we're looking good so far. Maybe that is the right answer. Outer. 3x times negative 4. Minus 12x. Now, take a look here. Now, this is unique. Negative 4 times 3x. Another minus 12x. Negative 4, positive 16. Okay, maybe we're close. Maybe it's just a plus 16. What happens on the inside, though? Do those cancel?
Yeah. No.
Negative 12 and negative 12 make
24.
negative 24. So this actually becomes a 9x squared minus 24x plus 16. So, was I even close? No. I wish it were that easy. But that is a very common misconception, to just write it as 9x squared 16, done. You can't do that. You cannot distribute that power like that. You know what we could distribute the power into? If there were if there wouldn't have been a minus sign there and it would have been all multiplication, then I could distribute the power in. But since I put an addition and subtraction sign in there, I got to use the FOIL method.
Can we just put this in our calculator? Would it give us the same answer? Or like...
How are you going to put an X in your calculator?
Good point.
Okay, so we finished the notes for today. You should be fine with the homework. Here's the deal. Everybody look up here. You know what this says? Original problem. Here's what I need you guys to do. For every problem in the homework, I want you writing the original problem down again. Take it out of the book, put it on your page. Why? Because I want you doing these markings on your paper. Yes, I want you drawing in the rainbows. Some people call this foil man. Look, eyes, nose, mouth, foil man. I gotta see foil man. Okay? You don't have to draw in the eyes, but I want to see all of that in there. Okay? Make sure you write down the original problem, mark it all up, then put your answer. Sound good? Perfect timing. Let's go.